Solution of linear system of equations by elimination method. Reduce the given system of equations to an equivalent system with integral coefficients and then solve by using the elimination method. The given system of linear equations has two equations in two variables, x and y. But the problem with the system is that the coefficients here are fractions, which are comparatively harder to solve. So our first task would be to convert this system into its equivalent system with integral coefficients. Therefore, let's get started and name our first equation of the system as equation 1 and second equation of the system as equation 2. And let's take a look on the denominators and find out LCM of denominators in equation 1. So LCM, let's write it down. LCM of denominators in equation 1 is what? It is 12 because the denominator has 4 and 3 numbers, 4 and 3. And what is their LCM, least common multiple? Mean the number on which both of them can divide easily is 12. So 12, and let's write down the equation here. That equation is 1 over 4 x plus 2 over 3 y equal to 1. This is the equation. What we are going to do, we are going to multiply the entire equation with 12, and similarly we are going to find out LCM of denominators in equation 2. So in equation 2, what is the LCM? That is 5, because there is only one number in the denominator, and that's 5. So we will be multiplying 5 throughout for equation 2, which is x minus 1 over 5 y equal to 3. And this still is equation 1 and this is equation 2. So when we are multiplying these numbers with equation 1 and equation 2, what we get here is, if we write in detail, 12 times 1 over 4x plus 12 times 2 over 3 y is equal to 12 times 1, and here we have 5 times x minus 5 times 1 over 5 y is equal to 5 times 3. So this is equivalent system, and we can still name it as equation 1 and this as equation number 2. And if we multiply 4 3 times, and this will give us 3 4 times 12, and 5 1 time is 5, and the simplified system can be written as 3x plus 8y is equal to 12. That is equation 1. And the second equation which we have here is 5x minus y is equal to 15. That is equation number 2. So from this system we can apply the elimination method to solve the system and get the values for x and y. For elimination method, what we do is we write down the coefficient of x here. So the coefficient of x in both equations. So we also write coefficient of x in second equation. And what are the equations here? The first equation is 3x plus 8y is equal to 12. And what is the coefficient of x? That is 3. And what is the coefficient for second? That is 5. And the equation is 5x minus y is equal to 15. And we do a cross multiplication, like coefficient of x in second equation, we multiply it with equation 1, and the coefficient of x for first equation, we multiply it with equation 2. So this was equation 2 and this was equation 1, which ultimately will give us equation with equal coefficients of x. So let's do this. This will give us 15x plus 40y is equal to 60. So when we multiply 5 throughout equation 1, that is what we get. And for second equation, when we multiply 3, this is what we get is 15x minus 3y equal to 45. This is equation 1 and this is equation 2. In order to get the value for y by eliminating x, what we do is subtraction. Subtraction, that is a standard procedure. Subtraction, and while we do subtraction, we change signs for equation 2. This plus 15 will become minus 15, this will become plus 3, and this will become minus 45. So we can cross this, and 40 plus 3, this will become 43. Y is equal to 60 minus 45 will give us plus 15, giving us y is equal to, so if we have 43, y is equal to 15, and we want to isolate y, what we do is we divide both sides by 43, and this will give us y is equal to 15 over 43. And now we perform the same operation for getting value for x. So what we do is we write coefficient of y for first equation as well as coefficient of y for second equation. What is the coefficient of y for first equation is 8, and the coefficient of y for second equation is minus 1, and we are going to write the equation 1 here, and that is 3x plus 8y is equal to 12. 3x plus 8y equal to 12. And the second equation is 5x minus y. 5x minus y is equal to 15. So this time we do the same thing. We multiply the coefficient of y equal to minus 1 with equation number 1, and coefficient of y here we multiply with both of these equations. So what gives us minus 1 time 3x plus 8y equal to 12, and here what we do is 8 times 5x minus y equal to 15. So when we perform these multiplication, this still is equation 1 and this still is equation 2, because we are only multiplying a constant number on both sides of the equation. So this will give us minus 3x minus 8y equal to minus 12, and the second equation will give us 40x minus 8y is equal to 120. So this is still equation 1 and this is still equation 2. And remember, our objective was to gain the equal coefficients of y by multiplication of these coefficients with alternate equations, which we can see that minus 8 is coefficient of y in both cases. And now we do the subtraction process. That's a standard procedure in elimination method, subtraction. And for that purpose, what we are going to do, we will be changing signs here. Minus will plus and then minus here. So this will get eliminated. That's why this is called elimination method, because one of the variable gets eliminated. So this is again minus 43x, and on the other side this becomes minus 132. And if we divide both sides by minus 43, so from this what we get is minus 43x divided by minus 43 to isolate x equal to minus 132 divided by minus 43. This will give us the value of our x, and that is 132 over 43. And the solution we get, so for solution, or what we call the point of intersection, is 132 over 43. And what is value for y here? We have already calculated that value is 15 over 43. 15 over 43. And this point must lie on both of those equations if we want to verify. So we can start verification process, verification, and for verification, we write both equations on either side. So this is 3x plus 8y equal to 12, and on the other side of this line we can write 5x minus y equal to 15, and we will be replacing x with 132 over 43 and y with 15 over 43, and we'll see if both of these equations contain this point. For this purpose, let's replace x 3 times 132 over 43 plus 8 times y is 15 over 43 and equal to 12. This is 3 times 43 is equal to 6, 9 and 3 here, that is 396 over 43 plus 8 times 15. 8 times 15 is 120. 120 over 43, and this must be equal to 12. And if we simplify this, 396 plus 120 will become 516 over 43, because the denominator on left hand side is same, 43. Therefore the addition process is pretty simple, and 516 divided by 43 is equal to 12. So this is true sentence, means that the point lies on the line 3x plus 8y equal to 12. Similarly, we replace x with 132 132 over 43, here minus 15 over 43 equal to 15, and when 5 is multiplied with 132, it becomes 660 over 43 minus 15 over 43 must be equal to 15, and because the denominator is same, therefore we are only going to add or subtract the denominators. So 660 minus 15 divided by 43, and this is equal to 645. 645 over 43 is equal to 15, and 645 over 43 is 15 equal to 15. Again, the same point lies on the second line, 5x minus y is equal to 15. Therefore, both of these straight line, one is 3x plus 8y, 3x plus 8y is equal to 12, and the other line 5x minus y equal to 15. Both meet in a point P which has coordinates equal to 132 over 43 and 15 over 43. Therefore, we used elimination method first to reduce it into an equivalent system with integral coefficients, then we solved it, and then we verified that the point of intersection lies on both lines.